Video we're going to talk about Grignard reactions, and usually you'll see Grignard reactions with some sort of R bonded to magnesium bromide. Now this bond is ionic, right? This bond is ionic, and so remember from general chemistry, in ionic bonds, right, the ions tend to form, first of all, an ionic bond is composed of a metal and a non-metal, right? So you could imagine the metals always tend to lose electrons. Your nonmetals tend to want those electrons, right? So your nonmetals are usually nucleophilic, right? They have some sort of negative charge. They want those negative charge, while those metals, right, tend to form that positive charge. They would much rather give up those electrons. So with that being said, you'll see something like this. Now this is phenyl magnesium bromide, or no, that's not phenyl, but this is a ring bonded to a magnesium bromide. Now remember, again, this metal is slightly positive, this carbon is very nucleophilic, and this is actually an excellent nucleophile. All right, so what if we were about to take this kind of reagent and react it with acetone? What would be the product? Well, again, remember, our carbon here is slightly nucleophilic, right? Slightly nucleophilic is very nucleophilic, rather, right? So the first thing, and remember, this oxygen is slightly negatively charged, so this carbon has to be slightly positively charged. And again, this bond between this carbon and oxygen is very polar, right? So in the first step of the mechanism, nucleophilic carbon comes in attack, kicks off the electrons on the oxygen. Now, usually with Grignard reagents, you'll have to do some sort of acid workup, right? You have to do some sort of acid workup, which is just some sort of H plus ions that the oxygen needs, right? And so you'll get this. You get a carbon that is bonded to a carbon, two other things, and an oxygen is negatively charged, right? And this is in the second step where we add some sort of acid workup. And it could be any acid, H3 or plus. It comes, grab one of these hydrogen, kicks in and form water, right? So now you get something to look like this. You get tertiary alcohol. Now, the thing with these reactions is that you actually have to run them under anhydrous conditions. And so that means no water, no water, no water, no water. So what if you were given this same molecule here, right, and you react it with carbon dioxide? CO2 kind of looks like this. And in the second step, you do some sort of acid workup. What would happen? Well, again, you could imagine these oxygen withdrawing electron density away from the carbon, so it's slightly electrophilic. Now, this carbon is slightly nucleophilic. So in the first step in the mechanism, it comes and attack the carbon. One of these bonds kicks off on the on the oxygen, and you get something to look like this. Right, you get something to look like this: an oxygen that has a double bond, and an oxygen that's deprotonated. In the second step of the mechanism, some sort of H plus source comes in, and the oxygen grabs that, right? And look what you form. You form benzoic acid. Right. Now, what if I were about to give you this here? This ketone here, and I say react this with methyl magnesium bromide in the first step, and then some sort of H plus in the second step. What would be the product? Well, again, metal is positive, so that means our carbon has to be very nucleophilic. So it comes, attacks, kicks off the oxygen, kicks off the electrons on the oxygen, and you get something to look like this. And an oxygen that's negatively charged with a methyl group on that carbon here. And the second step, H plus comes in, takes that, and we get a tertiary alcohol. And these are the just general premise for Grignard reactions.